Hello everyone, can you hear me? Okay, all right. So just before I start, I want to make sure of competitive audience. Uh, how many of you are familiar with Debian and Ubuntu packaging, workflows, things? Okay, sure. This does require some intermediate level knowledge, but even if you don't know the concepts, I hope you have some terms and details that you can remember and think, hey, Guruprasad, talk to me about it. Let me go and check his slides. All right. Before I start, I just want to warn you that even though I'm presenting like an authoritative person on this topic, I'm primarily a Launchpad developer. My knowledge of Ubuntu and Debian packaging is limited. There are probably people in the audience who know more than me. I might have made some simplifications for the sake of presentation or time. Please bear with me though. Okay. So all the packages in Debian and Ubuntu start their life as a source package. So what is a source package? Source package is basically going to consist of these three main entities in these boxes. The first is the Debian source control file. The second is the unmodified upstream table and the Debian packaging metadata and files that get added by Debian packager. I will try and show examples for some of these, but basically the way this works is, let's say there's an exciting application that you see on GitHub that's permissively licensed, so you want a package. So you get the upstream table, you add a Debian subdirectory, add all the packaging related configuration and metadata, and then you run some commands, you get the source package, and then you upload it. So that's how a source package is. One thing to keep in mind is whatever you install on your computer using commands like apt are binary packages, and those binary packages are built from these source packages. And the other correlation that you often have to remember is one source package can generate one or more binary packages. So let's say there is a source package called PostgreSQL. The PostgreSQL package might give 10 binary packages like the server, client, libraries, headers, common things, and so on. So the mapping between a source package and a binary package is one to many. Here is an example of a source package DAC file. DAC stands for Debian Source Control, I think. And this contains a lot of metadata describing the source package. And as you can see at the top of the contents, there's a PGP signature. So this is signed by the uploader who uploads the file and so on. It contains the name of the source package, what binary package it produces, what architectures, what version, all those things. So it also contains details about who's the maintainer of this package in Debian, upstream maintainer, upstream project link, and a bunch of additional things that you can always check and read from the manual. I also want to quickly elaborate on the Debian packaging stuff. So I mentioned that there is a Debian package directory that typically gets added by a Debian maintainer. This is the snapshot of the Debian directory for the hello package, which is the GNU hello utility that prints hello world in multiple languages and has a lot of tweaks. Some of the files of interest here are the rules file, which tells the Debian build machinery how to take the source package and then build a binary package from that. Again, we're not going to go look at the details of that file because you can take many days and still not understand many of the details. There is also the control file, which again is very similar in nature and format to the control file or the DAC file, where it describes the source package in terms of its build dependency, and then it defines what binary packages are produced from the source package, runtime dependencies, and so on. The changelog file contains information about what's the current version of the package, what are the changes, who's the packager who uploaded it, and all those things. There are more files that you can also see, like patches, because sometimes when you take an upstream package and want to package it for Debian or Ubuntu, the upstream source might not be usable as it is. For example, Debian has a very strict policy on what's allowed in terms of package behaviors and so on. So if they see some anti-patterns or privacy invasive behavior, the Debian maintainer might decide to patch it out. So these patches are typically placed in the patches directory, and then there is a series file which contains the order of the patches, or in which the patches should be applied to the upstream source. So let's come back to the topic of the presentation again. So the workflow. So let's assume that you are a Debian package uploader or maintainer, and by some magic you've already created the source package. So you're going to build the source package using your build tool of choice. There are various options possible. You can use the dpackage build package command, which is the most arcane and low level way of doing it. There is a debuild command. There are more abstraction layers on top of it that you can use. Let's say you somehow know how to build the source package, and then you sign it with your signing key. So this signing key is going to be a pretty important factor in the process, primarily because it's going to allow the upload processing system to verify that it came from you, or if it came from a user who's authorized to do the upload. And once you build the source package, you will have a .changes file, which is going to describe the changes in the source package after it's built. And you're going to use a command like dput or dput-ng to upload it to an archive. At this point, you have two choices. If you are an Ubuntu developer with upload rights of some sort, you want to have your packaged version published to Ubuntu, you end up uploading it to upload.ubuntu.com. Or if you're someone who is just an aspiring developer or you want to do some personal projects, you might want to put it on a Launchpad PPA, in which case you're going to upload it to ppa.launchpad.net. Dput command defaults to using anonymous FTP by default, but you can also configure it to use authenticated as FTP as additional layer of authentication. Once the upload is done, the role of the developer is over. It's over to the machinery in Launchpad to process your upload. So we have an upload processing mechanism in Launchpad which does a bunch of things I'm going to try and explain. There's a validation step which makes sure that the files that you've uploaded are actual source packages or things that Launchpad can know about and process. It's going to verify that it's been signed by someone who has permissions to upload to a given archive and parts of the archive. It's also going to make sure that you have the permission. For example, the Ubuntu archive has a detailed list of permissions. So for example, if you are someone who doesn't have upload rights, you need to find a sponsor. If you're someone who's a MOTU, which is an abbreviation for Master of the Universe, you're allowed to upload only to the Universe section of the repository. If you're a code dev, you can upload anywhere. If you're a security team member, you can upload a security pocket and so on. So all these checks happen at this point. The upload processor also performs some consistency checks in terms of, hey, does this upload make sense for the given archive in terms of the version number? Let's say the current version of a given package is 1.2 and you're uploading 1.1, it makes no sense, right? Because the version numbers always go up and it might say, no, hey, a newer version is already in the archive. Sometimes people also try to upload a version. Due to some reason, they realize that it's bad, so they try to fix the version and then upload it to the same number. And Launchpad will not allow you to do so because version numbers, once published, are immutable in the context of an archive. So you can never reuse a version. Once this is all done, you get some email notifications in most of the cases saying, hey, your upload was accepted or it was rejected for some reason. There is a specific corner case, which I'll cover in the next slide, where you won't get an email, but in most cases, you will get an email from Launchpad saying your upload was accepted or rejected. Once the upload is accepted, it's going to get queued in the queue for a given archive. It could be a PPA, it could be the Ubuntu archive, and then specific parts of the archive. And then at this point, there is going to be pending publication records created for the source package. So the whole publication process involved two steps. One is where you publish the source package, the DSC file, the original tarball file, and the Debian packaging metadata file into the archive. And then once the source package is built into all the binary packages that it can produce, all the binary packages, the .deb packages that you can apt install, those are also going to get published to the archive. So there are two steps. So this step creates the pending publication records for your source packages. It also schedules the binary builds for a given source package. It reads the metadata in the source package file and then finds out what architectures it needs to build on and then schedules the build. At this point, a frequent question that we get from a lot of Ubuntu developers, new and old alike, is, hey, I did an upload, dput worked fine, I got a success message, it has been like 3 or 4 hours, nothing happened. And they come to us and ask. So here are the 3 common reasons why this could be the case. So the most common reason is that the upload is unsigned or signed with the wrong key. So the upload must be signed with your signing key registered on Launchpad, the GPG key. And that's how Launchpad knows that you are who you claim to be, and then it allows it. If you have signed it with the wrong key or if you have not signed it, Launchpad will log a message saying that, hey, this is untrusted signature, but it will not send an email primarily because it doesn't know that it was you who uploaded. So if some random users try to upload packages to your archive, it makes no sense for Launchpad to spam you where you are not involved at all. The other thing is, if you've recently generated a GPG key and uploaded it to Launchpad, key server protocol is a distributed protocol, eventually consistent protocol, which means there might be a slight delay from the time you uploaded your keys to the key server versus it being available to Launchpad. So Launchpad might still reject your upload silently because of that. In some very rare cases, the upload processor might be having issues. or the Launchpad team, my team might have stopped it for performing some maintenance or something like that. In which case, the best bet is to come and ask us for help. So we have an active presence on Matrix on the Launchpad channel on the ubuntu.com home server, or you can submit a question on answers.launchpad.net/launchpad, which is the Q&A portal for the Launchpad project. The next frequently asked question that we see is, hey, I uploaded a package, it got published, but there is a silly bug. I'm ashamed of that. I don't want people to ever see that I uploaded that package. So what I'm going to do is, I will delete that package and then try to republish the good version. So like I mentioned already, Launchpad treats version numbers and the associated contents as immutable, which means once you publish a version of a package, either source or binary or both, Launchpad will never ever allow you to reuse that, even if you think you can be smart and delete it. But this is only in the context of a given archive. So if you have PPA1 where you did this, you can depublish the same version on PPA2, which is a separate namespace. The only way forward is for you to increment the version number and then publish the good version. Just a note here, you need to keep in mind that Debian has detailed rules on version comparisons, what patterns and paradigms that you can use, so that the version number you pick is compatible with the newer versions that might come up in the archive versus still being greater than the older version. And you should definitely read the Debian documentation for this. Again, if you run into issues with that, please reach out to us and ask us a question, and I'll be happy to help. At this point, I had mentioned that there'll be a queue to which your uploads will be added to, and there is an approval process that needs to happen. There are certain cases in which the approvals are automatic. For example, if you upload something to a PPA that you have upload rates for, or you own that PPA, those are automatically approved. Similarly, when there is an Ubuntu development series, currently the Ubuntu development series is 2604, which is Resolute Raccoon. And if you have upload rates to that and the Resolute Raccoon series is not frozen for some reason, it'll be auto accepted. In almost all the other cases, you need to keep in mind that this requires approval by an administrator of the queue. When I say admin, it could be a human or some tooling or automation that takes care of checking some prior criteria and then letting the upload get approved. A couple of examples where this might be required are for SRUs, which is the abbreviation for stable release update, meaning when you want to add an update to an Ubuntu release that's already out, you need to go through a stable release update process. So that requires approvals. And then whenever there are uploads happening during a freeze, you will need an approval from a queue admin. Once this is done, the publisher kicks in, and let's quickly talk about what publishing means, because I've been mentioning publishing a few times already. Publishing is basically the act of putting the pending package files, source and binary, on disk somewhere so that it's accessible to clients like apt, so that you can do an apt update and then see the files. But that's not enough though. For apt and other clients to be able to use these updated files, the archive has metadata files which need to be updated to include information about your new files, and those also need to be signed by some signing key that your system trusts. In case of the Ubuntu primary archive, there is an Ubuntu archive keyring package which is shipped on all Ubuntu machines, so it will be signed by one of the keys in that keyring package. Or for PPA, it will be generated by a signing key of the PPA. There is also another important step that needs to happen, where when you upload a given version of a package, all the older version of the package should be superseded and moved out of the way. So superseding also happens in the publishing process. And in specific cases, once the publishing is done, you might also need to sync external archives. For example, the primary archive is hosted on infrastructure that Canonical owns, but then there is a trigger for us to say, hey, we have published a new copy of the archive, sync, and then the Canonical mirrors get synced, and then from Canonical mirrors, all the community mirrors get synced. So whenever you see a term called FTP master, that refers to the primary Ubuntu archive. So there are two publishers that Launchpad takes care of, where FTP master publisher is the one that publishing Ubuntu, and PPA publisher is the one that publishes PPAs. A typical run of a PPA publisher finishes under 30 minutes, and then the primary archive publisher can take 1 to 4 hours of time. This is something that we are looking into improving, depending on the amount of work that the publisher has to do in each run. At this point, the uploaded source package that was pending publication gets published, and then the binary packages get built on Launchpad build farm. So you have to keep in mind that whenever someone uploads an Ubuntu package, they need to upload the source package. They can't build it on their computer and then publish to Ubuntu. The binary packages are built on the Launchpad build farm in a trusted environment, signed and then published. So the build output is again going to go through similar upload processing as a source package and then saved in Launchpad librarian, which is just a Launchpad storage system. And then pending publication record for that is created. And then when the publication records are scanned by the publisher during the next run, the publishing happens. So the deb packages for your architectures are on disk. At this point, it's important to note that whenever one architecture's packages are ready, those get published. The Launchpad publisher does not wait for all architectures to be built before it tries to publish the packages. At this point, clients like apt can access the archive and then get all your latest and greatest packages. Since I have under 5 more minutes, I want to quickly cover some extras. My presentation was supposed to end here, but I'll still try to cover some extras. So here is how the Ubuntu archive looks like, the top level. The disk directory contains all the metadata indexes. The pool directory is where you have all the goodies, like the source package and the binary package. You have, under the disk directory, you have a lot of suites. A suite is basically the name of the series, and a pocket. We have a lot of pockets. And inside a suite, you have files like this, where the top level metadata file is called the release file or the in-release file. These are the files that are signed and verified. Inside the in-release file, you have some metadata, which contains the checksums of other index files, which again contain metadata of other files. So it's all checksums and verification all the way down to your deb packages. Somewhere within the archive, you also have the packages.gz, which contains information about all the binary packages in a given part of the archive. An example is metadata like this, where it describes the hello binary package in terms of where in the archive it is present, where it says pool/main haste hello something.deb. So app will know that it needs to go and download the file from there. It also contains additional metadata that you can review later. There is also a sources.gz somewhere, which contains an index of all the source packages in Ubuntu in a given part of the repository, where it describes the source package and all the files that are associated with the source package. And with that, I'm done. So thanks.